Myself, Dr. Jibran Ahmed presents to you Simply Pathology, and today we are back with a very important session. We are going to read about artificial intelligence today. Now, this is a very important topic from your exam point of view, and remember that this topic is 110% going to be asked in this year's MD DNB 2025 examination. So, this is going to be asked, okay, because artificial intelligence has also come in the recent advances 27. The chapter number 1 is dealing with artificial intelligence. So this is a very hot topic for today's topic of discussion, and especially in 2025, okay, in this age, artificial intelligence, chat GPT and so many new things are coming up. So this is one of the important topics for this year's exam. Now, why this session is very important for you people to understand? Because artificial intelligence is an extremely difficult topic to understand. So I have tried to my level best to break down, okay, this topic, okay, in such a way that you are able to understand it very easily. So please pay a lot of attention while I am describing each and every point. Now, for ease of understanding, I have divided this lecture into two parts. So in the first part, that is in today's topic of discussion, that is in part 1, we are mainly going to discuss what AI is, what are the basics of AI, what are the different components, what is an artificial neural network, the components of artificial neural networks, the learning and the various architectures of artificial neural networks. So we are basically going to have a basic idea of how artificial intelligence works, what are the different architectures, and how, you know, we are basically going to use it, okay, in the field of pathology, how we are going to use it, or how we are going to apply it in the field of pathology and how it works, okay, in image analysis. So this is the part that we are going to try and understand today. Okay, in the next lecture we are mainly going to discuss about the part 2, wherein we will discuss about the applications of AI in diagnostic pathology, including the prediction of molecular features, okay, from histopathological images, okay, which is a very hot topic in recent advance 27. Okay, along with that we will also see what are the disadvantages, what are the challenges in relation to the artificial intelligence, and what are the solutions which are available to overcome those challenges, okay, in the current era, in this particular era. Okay, so this is how we are going to discuss artificial intelligence. So without wasting any time, let us begin today's topic of discussion, artificial intelligence in relation to the field of diagnostic pathology. So what is artificial intelligence? It is actually defined as simulation of human brain intelligence by machines, either by learning or by reasoning or by self-correction. So try to understand, in this world we are having, computers, okay, which is basically having softwares which are designed to do so many tasks, right? But yet they cannot match the human brain, because a computer by itself cannot act. A human has to sit over there, he has to do some coding or some work he has to do, and then that particular computer follows the instruction given by the human beings, and then it is carrying out. But what is artificial intelligence? Over here also the machines are going to operate, but the machines, they will have a decision making by their own. They will try to act like a human brain, and that is how artificial intelligence is different from whatever softwares or whatever computers that we have today. So artificial intelligence is basically acting as a software which is going to train a particular machine to act and behave as a human without the need of any human being. So that is what the artificial intelligence in very short is. So this is what your artificial intelligence is. So artificial intelligence techniques includes a lot of different techniques. So the most important techniques include machine learning and DL, that is your deep learning. So these two are the most important techniques of artificial intelligence. Okay, so what is machine learning? It is based on machine learning to make predictions based on input data and algorithm. That is what is machine learning. And what is deep learning? This is a type of a machine learning which is focusing on artificial neural networks or artificial neurons. So machine learning is basically, you are giving some input data and you're giving an algorithm that, okay, if the input is this should be the algorithm, this is the output. If the input is this, then this is how you have to go. If this is the input, then this is how you have to go. So you are basically, this is a very linear kind of an equation. But deep learning, it is also a type of machine learning, but it is based on the concept of artificial neural network or artificial neurons, wherein the artificial neurons, they are behaving or trying to simulate like a human neuron or biological neuron, and then they are using some information and data so as to interpret other information, okay, by itself without any input from the human beings. Okay, so deep learning is a more complex process, and more about deep learning we will discuss in the later half of the lecture. What are the other techniques of artificial intelligence? It includes robotics, natural language processing, and computer vision. So these are the 5 important AI techniques. Out of them, machine learning and deep learning are very important, okay, and they are used in day-to-day AI applications. Okay, other AI techniques includes robotics, natural language processing, and computer vision. So AI methods are being utilized in the field of pathology for image analysis and image segmentation. Now, what is the meaning of image segmentation? Segmentation just means, for example, you are concentrating on that part of image which is of interest. For example, the tumor area in a particular H&E slide. Okay, that is what image segmentation means. So AI is being utilized in the field of pathology for image analysis and segmentation, okay, ranging from simple task, example object recognition, to more complex task of using image patterns to predict diagnosis, prognosis, therapeutics, and even classification. So AI in the field of pathology, they can be used for multiple scenarios. For example, it can be just used to know what is this, to recognize a nucleus, whether the nucleus is low grade or high grade, what is the texture of the nucleus, okay, so whether nucleoli is prominent or not. So this is object recognition. So these are some of the simple things that AI can do. To more complex activities, for example, using the image, just by looking at the image you can predict what the diagnosis is, or how the prognosis will be, whether the prognosis is good or bad, whether you can classify a particular tumor looking at just the image, and what are the therapeutics which will be suiting to just from the image, so as to suggest the treatment as well. So these are more complex activities of AI in the field of pathology. Okay, so AI can be used in the field of pathology in this particular aspect. Okay, starting from simple task as object recognition to more complex tasks. For example, you are predicting the diagnosis, prognosis, classification, as well as therapeutics. So AIs primarily tries to automate the tasks that are time consuming for the pathologist, thereby helping in faster and more reliable diagnosis, thereby meeting increased workload demands. Okay, AI helps in morphometric analysis, thereby helping in spatial interrogation. So what is the spatial interrogation? So looking at the H&E slide, the hematoxylin and eosin slide, just you look at the H&E slide, okay, the AI can help in capturing the nuclear orientation, the nuclear chromatin texture, the nuclear shape, size, and the overall architecture can be understood just by looking at the H&E image. So this is what the AI can do just looking at the H&E slide. Okay, helping in the morphometric analysis. AI aims to provide support and assistance to pathologists and laboratory technologists so as to increase cost effectiveness. How? By better allocation of resources. Secondly, more consistent diagnosis with decreased inter-observer variability, by decreasing the inter-observer variability. And thirdly, by reducing the turnaround time, that is TAT, by reducing the turnaround time. So this is how they are helping the pathologist and the lab techs. Okay. Now, what is deep learning? So if you remember, I have mentioned that there are different AI techniques. Okay, out of them the two important one was machine learning and a variant of machine learning, that is deep learning. And deep learning, as I told you, they are based on artificial neurons or artificial neural network. Okay, so basically a deep learning is a type of machine learning that employs the use of artificial neural network. Just like we have biological neurons, so basically we are creating an artificial neuron, that is called as artificial neural network, and this is making use of multiple hidden layers, okay, more than equal to 2 and may go up to hundreds of hidden layers. So what are these layers? I will try to make you understand. So any artificial neural network, remember, they are having one input layer, they are having one hidden layer, and they are having an output layer. Okay, so whenever any artificial neural network is employing more than equal to 2 hidden layer, in that case that type of learning is called as a deep learning or a So DL always makes use of artificial neural network, and such kind of artificial neural network which is utilizing multiple hidden layers, at least two hidden layers are being utilized by an artificial neural network. Such kind of learning is called as a deep learning. So to understand the concept of artificial intelligence, we have to understand what an artificial neural network is. It tries to simulate the human brain, the biological neuron. So artificial neural network, artificial neural network, it simulates the human brain, sometimes surpassing the human cognitive ability as well, and overcomes the limitations of any ordinary computer. As I told you that ordinarily we have a computer, we have machines too, so you are giving some instruction and they are performing that, right? But what about, without your input, the machine is understanding what you want or what is need to be done, and it is doing that. So for that you require a special type of intelligence. That is basically what artificial intelligence is. And sometimes this artificial intelligence can even surpass the human ability, human cognitive ability. That is the power of AI. So artificial neural networks are software programs that can learn from circumstances and solve complex non-linear problems, and can solve complex but non-linear problems. So the building blocks of artificial neural network. So this artificial neural network is having a building block. For example, the human brain, the building blocks and everything, we are having the neurons, the synapses and everything. Similarly, artificial neural networks, they have a building block that is called as perceptron, or also called as the nodes. They are called as perceptron or the node. So what is a perceptron or what is a node? It is a system which is able to learn its parameters in response to a series of input patterns. So you are giving a series of data to that. So by itself, that node is going to learn the parameters and what kind of response it should give in response to whatever input that you are giving. So just like the human brain is composed of multiple neurons, the artificial neural network is composed of multiple nodes or perceptron. And I will show you with the help of diagram. Do not worry. The nodes are going to receive input signal, which is then relayed or transmitted via the hidden layer to the nodes of the outer layer, and ultimately an output signal is given to the external world. Artificial neural networks, they have different layers. As I told you over here, in case of deep learning, that ANN, artificial neural network, they are having multiple layers. And whenever there are more than equal to 2 hidden layers, then such kind of artificial neural network and based learning is called as a deep learning. So as I told you, artificial neural network, they have different layers. So what are these layers? As you can see, I have exemplified over here an artificial neural network. So you can see there's an input layer and there are multiple nodes or perceptrons, forming the input layer. So input layer is having multiple perceptrons of the input layer or nodes of the input layer. Then you can see that we are having hidden layer. After the input layer, we are having hidden layer. Again, they are composed of multiple nodes, or multiple perceptrons. And then we are having an output layer over here, as you can appreciate, which is receiving signals from the hidden layer. So there are multiple, nodes present in the output layer. Now remember, the information is always relayed from one layer to the next layer in this feed forward manner. That is, in one direction only the information is going. The information is not going to go from input to hidden, again from hidden to input. No. So it's a feed forward kind of an architecture wherein the information is going from one direction to the other. So whatever information was coming here, that was the input for this layer, and whatever output is coming out from this is going to become input for this hidden layer. Subsequently, it is happening in the same manner. Now if we magnify, if we take one particular perceptron or the node and we magnify, we can see this is the node. It is receiving multiple signals like x1, x2, x3, xn, and then they are calculating a particular output, which is again relayed forward. So this is how basically an artificial neural network, these are the components of the artificial neural network, and this is how they work or function. So this is a layer, this layered feed forward organization of the network is the major architecture of deep neural network used in most applications of histopathological image analysis. And why we are saying feed forward organization? Because the information is going forward only. It is not going back. So whatever I have spoken about, I'm just going to read the working of artificial neural networks. So the nodes of the input layer will receive the input signals from the external stimuli, and they will produce output signal. Now these output signal will become the input signal for the other layers like the hidden layer, outer layer, etc. And finally, whatever signal you will get from the outer layer, it is going to go to the user or the external environment. Okay, remember, the outgoing signals are only allowed to subsequent layers and not vice versa. It will go in a feed forward or in a single direction. Okay, now we come to the learning of artificial neural network. Now if you see, there are different methods by which you can train a particular artificial neural network. So the learnings are of different types. Okay, let us understand. So this learning of the artificial neural network, it is the most important part of ANNs. It is a dynamic processes which is dependent on output evaluation, new input information, and alteration of weightage. So as you can see over here, there is some amount of weightage also that is given. Weight adjustment can also be done over here, okay, externally. Okay. So let us see what are the different kinds of learning of artificial neural networks. So number one, as we can see, we are having supervised learning. Now supervised learning, it is the most common learning paradigm. Okay, artificial neural networks are trained on certain labeled data. So there are certain annotated data or images, or certain labeled data or images are provided to the artificial neural network. Example, input label is paired with corresponding output label. So some information is given that for this input, this should be the output. I am giving you, that this is how, if this is what you see, this is the input data you see, then this should be the output that you should give. So over here, what you can see, that a lot of data we are only providing. So basically it is a supervised type of learning, that already I am telling you, this is the data, this is how you should react, or this should be the output. So for such kind of artificial neural network, they have to be trained using intrinsic domain knowledge. And over here, what kind of knowledge are we looking at? The knowledge of the pathologist and the oncologist has to be applied. So over here we are training the particular artificial neural network with the knowledge of the pathologist itself, because our what we require it for, we are requiring it for diagnosing the images or to get information from the images. So we are training them with our information. So we are giving the input data and we are also giving the corresponding output data. So all the labeled data is given, and over here remember, the machine has to be trained with intrinsic domain knowledge of the pathologist and oncologist. Okay, so such input output mapping is learned by the artificial neural networks, can be applied to even new data. So suppose you have given, as a pathologist, I have given so many data about different types of tumors and everything, the input output. Now whatever the machine or whatever the software, the artificial neural network has learned from this input data, it can also apply it to a newer data. This is what artificial intelligence is, that you are using whatever existing knowledge is there, but by your own your own thinking, you are also applying such kind of data to interpretation of a newer data. Okay, this is your supervised learning, wherein I am only providing all the information to the particular artificial neural network. Then there is something called as unsupervised learning. This is a very, very complex process. It is a very complex process. Okay, it is a very, very complex process. Over here, there is a training of artificial neural network with an unlabeled data or without any inherent domain knowledge. So I am just giving them data. Lots of data has been given to the particular artificial neural network, but I am myself not giving any labeled data. Okay, I am not giving that if this is this, that should be there. Okay, I am just giving lots of data. So artificial neural networks over here, in this case, they are expected to find out patterns or any representations in data without any specific guidance. Over here, we are not providing any knowledge from the pathologist or oncologist. They are not being applied over here. We are just giving or showing that particular artificial neural network some images we are giving. Now we are leaving it up to this particular artificial neural network to decide whether which pattern is what and what pattern is what, and whether it can take some salient features from that particular pattern that it is going to see in the several images that we are giving them or we are exposing them to. So this is an unsupervised learning, wherein we are not giving any labeled data to them. So there is unlabeled data. Okay, this is unsupervised learning, which is mainly a very, very complex process to train. Then there is semi-supervised learning. As you understand, over here we are combining both the supervised and unsupervised learning. It is useful in those conditions where there is huge number of pathology images but without any labelings or annotations. So where huge number of images are there but they are not having any kind of label. So in those situations, this semi-supervised learning is applicable. Then the next type of learning is the transfer learning. What is this transfer learning? This is a type of learning where knowledge gained in solving one problem is applied or transferred to a different but a related problem. That is transfer learning. Then there is self-supervised learning, which is used for learning image representation adapted to specific task in absence of any label data. So over here, whatever learning is there, it is adapted to a specific task only. That is a self-supervised learning. Then there is something called as weakly supervised learning and multiple instance learning. So it is giving the image and overall label. Now what is it? Over here what is happening? Usually in case we are using artificial intelligence and artificial neural network, that is the deep learning whenever we are using. So in pathology, we are labeling each and everything. Like suppose we will train the AI to recognize one particular object like the nucleus. What is the orientation of the nucleus? Whether the nucleus is dark or light. What is the texture of the nucleus? What is the overall architecture? So there are multiple things that they will recognize. So this is basically a highly specific process. But sometimes you do not require a very highly specific, but rather you require a very weakly supervised process. So this type of learning is going to train the artificial neural network. It is going to help it in predicting the image level or patient level labels. For example, what is the time to, so you have taken the overall picture, you have seen the entire image. Now you will say what is the time to relapse for such a histopathological image, or what is the overall survival of patients, okay, with a particular cancer with this image. So you are over here, you are taking an overall picture, you are taking some things into account and you are giving one particular label. Okay, according to this, the patient is either having a disease or it is not having a disease. So you are giving a single label over here, looking at that. So that is a weakly supervised learning or multiple instance learning. So here the artificial neural networks are trained to classify an entire image based on a global label. Example, presence or absence of a disease, without any indication that which part of the image is responsible for such a label. It is useful where detailed annotations are not available. Okay, that case they are used, this is very useful. So I hope you have understood the different kinds of learning of artificial neural networks. Now we are going to see the various architectures of artificial neural networks. So the first architecture was back propagation neural network. Now this was one of the earliest and most common type of neural network. It is a network consisting of input, hidden and output layer, as I have already shown you previously. Known labeled output, okay, is fed into the network, and by back propagation the weight of the node is adjusted after each iteration, or after each time the message is passed forward, the weight is adjusted. Okay, this process continues till the model reduces the error rate significantly. I will just explain it to you. So over here, as you can see, there is a feed forward architecture over here. Okay, so now suppose I have given one input and then I am expecting a particular output. Okay, and suppose the system is not giving a particular output in that time. So what I will do, I am going to adjust the output so that I get the desired level of output, okay, from the input. So there is a weight adjustment, that is the back propagation, and that the information is flowing, that is called as the feed forward propagation, okay, that we have already seen. So what is happening, that this back propagation neural network is basically used to reduce the error rate significantly. So whatever feed forward information is going, okay, I will do some weightage at the end so that whatever output I am getting, the errors are reduced. Okay, the errors are reduced. Okay. Now this back propagation is coupled with the feed forward architecture that I already showed you, that has allowed for practical training of larger or deeper artificial neural networks, okay, so that such kind of learning of artificial neural networks becomes feasible. So both the back propagation and the feed forward architecture, they are working together so that deep learning becomes feasible, okay, as exemplified over here. Okay, so over here we have done some weight adjustments so that the error rates are reduced significantly, and this is the feed forward architecture. So both the back propagation, from here there is the back propagation and this is the feed forward architecture. Both of them are together have made possible that deep learning becomes feasible. Okay, so this is the back propagation architecture. Then the feed forward we have already seen. Now we will see one very important neural architecture, that is the convolutional neural network, also called as the CNN. Now this is very important for pathology, because such kind of training is very important, because this helps very much in image recognition. Okay, this CNN type of artificial neural network, this pattern is very important for image recognition. So basically let us see what it is. So over here what happens, let me just explain you first, okay, then I will read. So suppose this is a particular HP image over here, as we can appreciate over here. This is an image, and suppose there are certain salient information that, for example, I require from a particular image. Suppose this is the area of interest. So I have put a filter over here. There is the filter which is going to focus on just this particular area. And whatever information, this is a very high resolution image, okay, whatever resolution, this high resolution area of interest is going to be constantly convoluted. It will undergo various layers of convolution, so that this high resolution image becomes a low resolution image. Okay, so and this low resolution image is going to go to certain areas where there will be pooling. In the pooling, what is happening, that whatever information that you have received from the convolution layers, okay, they are basically pooled, and the summary of whatever information is required is pooling over there. Okay, and then ultimately what is going to happen in the end, okay, there is basically one exit that is there, that is called as your FCL, that is fully connected layers. In the end, they are going to go, all the information will be received in the form of fully connected layer, and this information will be of a lower resolution. Okay, so a very flat image will be produced, which is having a lower resolution, easy to understand, easy to store, thus reducing the computational burden as well. So this is what is the convolutional neural network. So I will read whatever I have explained it to you. So if you see the convolutional neural networks, they are specialized type of a deep neural network. It is aimed to primarily process the data with grid-like organization. For example, the images. So over here you can see the images, they can be broken down into multiple grids. So grid-like information whenever you are processing. So in that case, the CNN type of architecture is very good for processing such information. For example, images. Therefore, unlike the conventional artificial neural networks, CNNs can extract features from images and process them accordingly. Now they are having three layers. This is a artificial neural network, a specialized variety called as CNN, that is convolutional neural network. And over here they are having three layers. One is the convolutional layer, then is the pooling layer, and finally you are having the fully connected layer. Okay, so remember over here, as the information is passed, okay, the image is becoming shorter and shorter and shorter, and this process is repeated again. I will show you. So over here the convolutional layer, so basically in the convolutional layer,